Okay, we'll come to the start of chapter 3 of your textbook of 4A. Okay, as you can see, chapter 3 is matrices. Matrices is the plural of the word matrix. So we have one matrix, many matrices. Then we can see Keanu Reeves and Lawrence Fishburne there. But today's lesson is not about the movie, it's about mathematics. So let's just close this and open up the presenter over there. And now, chapter 3, matrices. Okay, first, right, what is a matrix? Okay, I refer you to the your textbook, page 61. Okay, page 61, we have a definition of a matrix. For example, the table shows a volume of sales of components in two shops. So shop 1 sells 320 monitors, 358 printers, 107 scanners. Shop 2 sells 216 monitors, 195 printers, and 54 scanners. Alright. So if we want to represent this data into a matrix, right, what we do is we can write it like this: 320, 358, 107. Okay, and we have 216, 195, and 54. This is what is known as a matrix. Okay, next thing, right, is how do we what I call name, okay, the order of a matrix. Okay, basically the order of a matrix, okay, let me write the word order, okay, of a matrix, right, is given by the rows by columns. This is not multiply, this is rows by columns. So this way is a row, okay, and this way up and down is a column. Okay, in this case we have one row, two rows. So the order of this matrix is 2, and columns, right, column is a vertical one. We have one column, two column, three columns. So the order of this matrix is 2 by 3. Okay, next thing, right, is how do we get, right, the data from the matrix. For example, 358, right, we always say if I want a certain data, let's say 358, if I want 358, it is row 1, because this is the first row, okay, first row, and 1, 2, second column. So row 1, column 2 is 358. So that's how we get data from a matrix. Okay, now let's say if I want 54, okay, it is row 1, row 2, column 1, column 2, column 3. So row 2, column 3 is 54. And that is how we have the A, the order of matrix, and B, how do we actually retrieve data from the matrix. Okay, now I will now straight away delve into examples from exercise 3.1. So, and 3.1 can be found on page 64. I will do question 3. Okay, Jiali checks the price of MP3 player in 3 shops. She finds that the price is 150, 120, and 138. She represents a matrix by a 3 by 1 matrix. Okay, so 3 by 1 matrix, right, we have two ways of doing this. Okay, either is this, okay, or is it this one? They ask for a 3 by 1 matrix, so it's 3 rows, okay, and 1 column. This one has 1 row, 2 row, 3 rows, and 1 column. So this is the correct way of representing the data that they wanted. This is wrong because this is 1 row, okay, and 3 columns, and that's not what we want out of this. So I'll just cancel this out. Okay, this is wrong. I'm just giving you a negative example. Then now, part B. Describe the meaning of the element in the third row and the first column. Third row, first column is 138. Okay, so basically, right, what they're saying is that the price in shop C is $138. Simple enough. Okay, now I will do question 5B. Okay, 5B, it works like this. Then let me copy down the question. Okay, these two matrices, 2 by 3, 2 by 3, these are known as equal matrices because they are equated. So if they're equal matrices, what happens is that each element should be the same. For example, row 1, column 1 is 5, row 1, column 1 here will also be 5. Here, row 1, column 3 is negative 9, row 1, column 3 is also negative 9. So it goes to show that if row 1, column 2 is 7, row 1, column 2 over here also should be equals to 7. So I write x minus 2 is equals to 7. If you solve, x is equals to 9. Same concept applies here. Row 2, column 1 is 2y plus 1. Row 2, column 1 is negative 3. So I simply write down 2y plus 1 is equals to negative 3. 2y equals to negative 4. Y equals to negative 2. And that concludes all the examples I have for exercise 3.1.